Hi, I'm Mark Barsamian. In the previous video, I introduced the consumer surplus. That's a concept from economics. It's a quantity that can be visualized as the area of a region between curves and computed with a definite integral. In today's video, I'll introduce what's called the producer surplus, which is a related topic and visualized in a very similar way and computed a very similar way. This material is from section 6.2. More specifically, the middle of page 405 to the middle of page 406, example 6. Corresponding homework is just this single exercise from section 6.2. Recall the business terminology that we used earlier in the semester. We had the idea of the demand, small letter x, it's a variable that represents the number of items made and sold, and the price p, small letter p, a variable that represents the selling price per item. But in the previous video, I discussed how it's useful to slightly change the terminology to be more specific. We'll talk about the quantity demanded, which will be denoted by x or q for quantity. That is a variable that represents the number of items that consumers are willing to buy. And the demand price, denoted by little p, is a variable that represents the selling price that's necessary for consumers to be willing to buy the quantity x or q of that item. The value of the variable p is given by a function, d of x, called the demand price function. The graph of the demand price function is called the demand price curve. And recall that when the selling price is high, consumers will not be willing to buy many of the items. But when the selling price is low, consumers will be willing to buy a lot of the item. So therefore, the demand price curve will go down as you move from left to right. So here we have a graph of a typical shape for a demand price function. So again, this graph reflects the idea that when the price is high, consumers will not be willing to buy many of the items. But when the price is low, consumers will be willing to buy a lot of the item. And finally, recall the definition of consumer surplus. The consumer surplus for the demand price function d of x at the price point x bar p bar means the value of this definite integral, which corresponds to the area of this shaded region. This shaded region is a simple region with top curve d of x, bottom curve is the curve with height p bar, and the left endpoint is x equals 0, and the right endpoint is x equals x bar. So the area of that green shaded region is given by this definite integral. And what that means is the total amount of money that all consumers who are willing to buy the item at the price p bar will feel like they saved if the selling price is p bar. Now I want to talk about what I'll call the supply price. So far in this course, the discussion of selling price and quantity has always been considered from the standpoint of the consumer. When the selling price of an item is high, consumers will not be willing to buy many of the items. But when the selling price is low, consumers will be willing to buy a lot of the item. That's why the graph of the demand price curve will go down as you move from left to right. That is, the demand price function or curve, d of x, is a decreasing function. Now consider the producers of the goods. Realize that when the selling price for an item is low, producers of the item will not be willing to supply many of the items. But when the selling price is high, then producers will be willing to supply a lot of the item. So we need to introduce a function that will describe this behavior of producers. That's the idea of what I'll call the quantity supplied and the supply price function. So what I will call the quantity supplied, and I'll denote by either an x or a q for quantity, it's a variable that represents the number of items that producers are willing to supply. And the supply price, denoted by little p, is a variable that represents the selling price that's necessary for producers to be willing to supply the quantity X or the quantity Q. The value of that variable is given by a function denoted capital S of X or capital S of Q. I'll call this the supply price function. The graph of the supply price function is called the supply price curve. In light of our earlier observation about the fact that when the selling price for an item is low, producers will not be willing to supply many of the items, but when the selling price is high, producers will be willing to supply a lot of the item. In light of those observations, we can conclude that the graph of the supply price curve will go up as you move from left to right. That is, the supply price curve will be an increasing function. So for example, a supply price function could be this one, P equals 0.01x plus 50. So in this graph, we have the quantity supplied on the horizontal axis, and on the vertical axis, we have the supply price. So notice that it's the same variables that we used previously for the demand price. We had the X for the quantity demanded and the variable P for the demand price. Now we use those exact same variables, X and P, but we use them to mean different things. This is the quantity that producers are willing to supply, and this is the price that's necessary for them to be willing to supply that quantity. Let's consider a couple of sample points on this graph. This point has coordinates 2,000, 70. That means that when the selling price is $70, producers will be willing to supply 2,000 of the items for sale. This point has coordinates 8,000, 130. That tells us when the selling price is higher, $130, producers will be willing to supply 8,000 of the items to sell at that price. Suppose that the supply price function is the one that we have discussed just now, P equals 0.01x plus 50. And suppose that the selling price of an item has been established at P equals $80. We see on the S of X curve that the corresponding quantity is 3,000. When the price is 80, producers will be willing to supply 3,000 of those items. Now consider who would supply the item at this price. Well, any producer who would have been willing to supply the item for less than $80 will be willing to sell the item for $80. And consider how much extra money these producers will feel like they made. Those who were willing to sell for $55 will feel like they made $25 extra. And those who were willing to sell for $65 will feel like they made $15 extra. And those who were willing to sell for $75, well, they'll feel like they made $5 extra bucks if they were able to sell for $80 instead of $75. Well, the amounts of extra money that these producers will feel like they made can be illustrated on the graph of the supply price function. So here's this same curve again. We've got the quantity supplied on the horizontal axis. We have the supply price on the vertical axis. And the red line is that P equals S of X function. And finally, we have this horizontal dashed line at a height of 80. That's the value of the established selling price, which is denoted P bar. And we have the corresponding quantity supplied, that's 3,000, and that's denoted X bar. So now let's illustrate the extra money that these producers will feel like they made. The producers who would have been willing to sell for $55 are here. That point has a y coordinate of 55. If those producers are able to sell for $80, then they're going to feel like they made $25 extra. That's this difference in height between this point with coordinates 500, 55, and this point with coordinates 500, 80. The producers who would have been willing to sell at $65 will feel like they made $15 extra. The producers who would have been willing to sell at $75 will feel like they got $5 extra by selling at a price of $80. We see that the area between the supply curve S of x and the horizontal line with line equation P equals 80 and this should say from x equals 0 to x equals x bar, which is 3,000. That is, the area of this region will correspond to the total amount of extra money that all producers who sell the item will feel like they made if the selling price is $80. This region is just a triangle. We can find its area using geometry. Let's go back up and see the dimensions of that area. This triangle has a base of 3,000 and a height of 30 because this vertical coordinate is 80. So the triangle area is 1/2 the base times the height, so 1/2 of 3,000 times 30, so 45,000. So the total amount of extra money that all producers will feel like they made is $45,000. This idea can be generalized. In general, the supply price curve won't be a line, but it will be increasing, like this. And so the region won't be a triangular region, but it will be a simple region. The top curve is P bar. The bottom curve is the supply price curve. The left endpoint is x equals 0, and the right endpoint is x equals x bar. So the area of that region, which corresponds to the amount of extra money that the producers who are willing to supply the item at this price of P bar, the amount of extra money that they'll feel like they made if they are able to sell at this higher price of P bar, that area will be the result of a definite integral computing the area between curves. That resulting number, the area between those curves, is called the producer's surplus for the supply price function S of x at that price point x bar P bar. So this is the producer's surplus PS. The official definition is on the next page. The producer's surplus for the supply price function S of x at this price point x bar P bar is defined to be the value of this definite integral. Integrate from x equals 0 to x equals x bar, this integrand, P bar minus S of x. That definite integral computes the area of this simple region bounded by this top curve and this bottom curve, S of x, from x equals 0 to x equals x bar. Let's do an example. Suppose that the supply price function is this, P equals 12 plus x, and the selling price has been established as P bar equals 18. Find the producer's surplus. Well, we have to compute this definite integral. In order to do that, we're going to have to find the quantity, x bar, that corresponds to the price P bar equals 18. To do that, we just let P be 18 in this equation from the supply price, and we solve for x. The result is x equals 6. So that means that x bar is the number 6. The calculation of the definite integral will be on the next page. So we start with our form of the producer's surplus. We put in the endpoint, x bar is 6. We put in our P bar there, and we put in our supply price function, 12 plus x there. We simplify the integrand. We end up with this simpler definite integral. The fundamental theorem of calculus says we can find that definite integral doing this indefinite integral computation, and the rest is straightforward stuff. We end up with this value of 18. That's the producer's surplus. Question B, illustrate with a drawing. Well, the supply price curve, P equals 12 plus x, will be a line with y-intercept at 0, 12 and slope m equals 1. The price point, x bar p bar equals 6, 18, will be a point on this line. The height of this black dotted line is 18. That's the value of p bar. The y-intercept on that red graph is 12 because of that 12. Here's the graph of the supply price curve. And on the x-axis we have x equals 0 and x equals 6. So this red shaded region corresponds to that producer's surplus. Now that region is just a triangle. We can also just find its area using geometry. When we do, we get the area of 18, which is what we found before for the producer's surplus. That's the end of that example. Let's do one more example. In example 2, we are to find the producer's surplus at a price level of p bar equals 80 for the supply price function given here. Now that's quite a bit more complicated price function because it's got an x squared term. Well, the solution is we have to compute this definite integral. And in order to do that, we have to find the quantity, x bar, that corresponds to that price level, p bar equals 80. Well, that means we have to substitute p equals 80 into this equation, which is a quadratic equation. We have to solve for x. So we end up with this. Now we can solve this using the quadratic formula. I'll do that on the next page. There's a quadratic formula. Now let's review what our a and our b and our c coefficients are. Our a is 0.003 from there. Our b is 0.4. And our c is minus 70. So there you see I've substituted in the value of a, the value of b, and the value of c. When you do the computation, you end up here. Now we're only interested in positive x values because we're considering quantity of items that are going to be supplied. You can't have a negative quantity. So we only care about the plus in that plus minus. So our solution is there, x equals 100. So that means that our x bar is equal to 100. Now we're ready to compute the producer's surplus by doing that definite integral. Here's the definite integral calculation. We substitute in our x bar, which is 100. We put in our p bar, which is the value 80. We put in our supply price function, which is this messy quadratic function. We simplify the integrand before integrating. And we reach this definite integral. Now, the fundamental theorem of calculus tells us that we can do that definite integral by doing this indefinite integral calculation. The results are harder than the previous problem because the x squared term, but it's just careful arithmetic. There's the result of the indefinite integral. We do all the arithmetic very carefully, and we end up with a value of 4,000. Question B is to illustrate with a drawing. Well, the supply price curve, P equals 10 plus 0.4x plus 0.003x squared, that'll be an upward facing parabola with y-intercept at 0, 10, and this known point, this price point, x bar, p bar, equals 100, 80. That'll be another known point on this line. So there's that price point. Here's the y-intercept, and here is this horizontal line with height 80. That's the value of p bar. And here is the supply price curve. Now notice that this shaded region, of course, is a simple region. That's why we're able to do this. We have that definite integral calculation that will compute this, but that's not a triangle. We can't just compute this area using the triangle area formula. But notice that that shape is almost a triangle. What if we were to estimate this by putting a triangle in that's close to being the same size? let's do this. Let's draw a little triangle that fits inside, that is a right triangle. And let's compute the area of that triangle. Well, the base of this triangle is 100, and the height is 70. So notice the area of that blue triangle is 3,500, which is not too far off of the actual area of that red region, which is 4,000. Well, that's the end of that example. That's the end of the video. Thank you.